Hello, today we're going to lesson 4D, negative exponents, day 2. Today students will be able to simplify expressions with negative exponents. Students will be able to discuss patterns associated with negative exponents, and this is important for real-world problems such as representing the size of something very small as the diameter of a white blood cell. So today we're looking back at those negative exponents, so we want to remember what all this means. Remember, if we have 9 to the negative second power, we cannot write 9 negative 2 times. So we've got to make this exponent positive. In order to make it positive, remember we put a 1 on top. So put a 1 on top. Remember that changes the sign. And so in order to do that, let's look at it down here. We put a 1 on top and that changes the sign. So the way to look at this is 1 divided by 9 squared. So that would be 1 divided by 9 times 9, which means 1 divided by 81. So if we were to write this as a decimal, we would have to divide the 1 by 81. So let's look at simplifying when we have fractions and negative exponents. So in this case, we have 2/3 that's brought to the negative 2 power. Well, that's a negative 2 power. We cannot write 2/3 negative 2 times. That's impossible. So we need to make that positive. In order to make it positive, remember we put a 1 on top. Changes the sign. So what that really means is 1 over 2/3 times 2/3. Well, if we write it that way, we can see that it really is 1 divided by 4 over 9. But we can't keep it as the 4 over 9 because we have a complex fraction here. We have 2 fraction bars. We can't leave that. So if you want to think what this is actually equal to, it's 1 divided by 4 over 9. And we remember to divide by a fraction, it's the keep, change, flip. We have to multiply by the reciprocal. So what that really means is 1 times 9 over 4. And so our answer is actually going to be 9 over 4. So if we look back to what this originally was, it was 2/3, which means 2/3 squared, which means 2 squared over 3 squared, which gives us 4 over 9, but it flipped over. And so another way to write that, if we were to write this back with exponents, we could write 9 as a base 3 being squared, and 4 as a base 2 being squared. Since those are both being squared, our answer could also be written as 3/2 squared. Now look at how it ended, 3/2 squared. Looked at how it began, 2/3 to the negative 2. So it flipped over and the exponent became positive. And we'll see that happen because this is quite a long process to do all the time. But let's try it again. If they ask this, by the way, as an evaluated form, this would be evaluated. If they ask you to evaluate, which this one does, this would be exponential form. And we'll just write it as exponent, but that's exponential form. So let's go ahead and continue with this evaluation. We see a negative exponent, we put a 1 on top. Remember, that makes this exponent positive now, so it's 1 over 4/5 to the positive 1, which means I only have that 4/5 one time. 1 divided by 4/5, 1 divided by 4/5. Remember, keep, change, flip is really 1 times 5 over 4. And so our answer would just be 5 over 4 because this says evaluate. So because it says evaluate, we're going to leave it like this, not in exponential form. Let's try it again. Negative 1/3 has been brought to the negative second power. Remember, we put a 1 on top. Only changes the sign of the exponent. So that makes this 1 over negative 1/3, and we have it 2 times down here, negative 1/3. So when we evaluate, this really means 1 divided by, well, 1 times 1 is 1, 3 times 3 is 9, and a negative times a negative is a positive. So this would be 1 divided by 1/9, which really means 1 times 9 over 1, which gives us just positive 9. Let's try that again. We see a negative exponent, put a 1 on top, changes the exponent sign. So what this really means is 1 divided by, and this time we have negative 3/5, now 3 times. Because we put a 1 on top, we can now write it 3 times down here. Negative 3/5, negative 3/5. And now we can evaluate. So this means 1 divided by negative times a negative is a positive, times another negative changes it back to negative. 3 times 3 is 9, times another 3 is going to be 27. 5 times 5 is 25, times another 5 is 125. But we can't leave this complex fraction, and so we write it out. 1 divided by negative 27 over 125 is really 1 multiplied by negative 125 over 27. Keep, change, flip. Keep, change, flip. And so 1 times anything is just itself, and so we get negative 125 over 27. And we're going to leave it at that. Number 5. Now in this case, we see a negative on the outside. Remember, that means we're going to leave it for the end. We are going to put a 1 on top, which changes the sign of the exponent, so we can write it twice now underneath. The negative stays out front, and what we really have 2 of are the 3/4. 3/4 times 3/4. We have 2 of them. So now on the bottom, we would have 1 over negative 9 over 16. 3 times 3 is 9, 4 times 4 is 16, and that negative is just applied back onto it. Okay, 1 divided by, keep, change, flip, means I'm just going to get the answer of negative 16 over 9. And that would be our answer. Okay, let's try that one more time before we flip over to the back. I see a negative exponent, so we need to put a 1 on top. Putting a 1 on top changes that sign. And so what I really have is 1 divided by, negative is left on the outside, and now I have 1/4, the base 1/4, written 3 times. 1/4 times 1/4 times 1/4. Okay, so that's going to give me 1 over negative. 1 times 1 is 1. 4 times 4 is 16, times another 4 is 64. So remember, what this really means is 1 divided by negative 1/64. I know that negative is going to stay there. Keep, change, flip. 1 times 64 over 1 is just going to be 64. And so we get negative 64 as our answer. Okay, let's go ahead and look at the back. Evaluate the following expressions. So we're still evaluating on these. So I'll only do a couple of these that are the same as before. We'll look for any interesting cases, and then that'll be it for the day. So we see a negative exponent. We put a 1 on top, changes the sign. So what I really have is 1 divided by negative. Now this time the negative is included with the parentheses, and so that means it's sticking to the base. And so our base is going to be negative 4/5. Negative 4/5 times another negative 4/5, because I have 2 of them. A negative times a negative is a positive. We get 16 over 25. Keep, change, flip means my answer is actually going to be 25 over 16. There it is. Okay, so you'll see the other cases are pretty much the same as before, but I do see an interesting one at number 12. What do we see? It says negative 6/7 to the 0 power. And remember, 0 power means it is equal to 1. That negative is included with the base, so that entire thing changes to 1. They would all cancel out to 1. Looking past these others, it looks like they're all pretty much the same type of case until we get to numbers 15 and 16. That's where they get interesting again. So again, we see that we have a fraction bar. We have quite a few fraction bars. So let's write out what this means. Let's expand it. So I have negative 2/3 2 times. That I can write. There's no negative exponents there, so I can write that out. Negative 2/3 times negative 2/3 is up top. On bottom, I have 4 copies of negative 2/3. Negative 2/3 times negative 2/3 4 times. Now that I see it all written out, we see some matches. Even though they are fractions, I know that a matching up top and bottom is going to cancel out to 1. So those are going to cancel out. That'll leave me with 1 over, and then I have negative 2/3 times negative 2/3 still left there. Now this did say to evaluate, so I'm going to go ahead and evaluate that. This would be 1 over, negative times a negative is a positive 4 over 9. But we can't leave this weird looking complex fraction, so remember, keep, change, flip. 1 times 9 over 4 is going to give me 9 over 4. So that would be my answer. All right, I'd like you to try this on your own with number 16, or if you do have a device today, try it on the exit ticket. And as always, please let me know if you have questions. Otherwise, get started on homework. Yay, math.